So welcome. My name is Marcia Villalba, like James pronounced correctly. I'm a developer advocate for Serverless, and I've been doing Serverless from its early beginnings. And today, I'm going to talk about the best practices to design and build event-driven applications. As I say, I was building these applications from very early on, and there was not many instructions out there on how to do them. And I tried to build some event-driven applications as well. And sometimes I succeed, and sometimes I had many challenges. And I will say that most of my challenges started from the beginning when trying to build these event-driven applications, because I didn't know how to design these applications. I started throwing boxes in a paper or in a PowerPoint or wherever you draw your boxes and connecting things around, like we do with normal systems. That's how we always start designing. Let's grab a napkin and start throwing some arrows. But with event-driven applications, it didn't work that well. Let's see an example. This is an application. I will be going around through my whole demo today, so get familiar with it. And you're all familiar. It's an e-commerce. We get orders. We do things in the inventory, like get information from the inventory, remove things from the inventory. We process payments. We do deliveries. All the things that we do in an e-commerce. So in this example, basically, we get a new order, and then that new order, poof, sends an event. Then that event triggers a rule, and then again, and again. And now I want to start changing things, and this is not very cheap to change, because I need to start moving numbers around, so unless I started my drawing with a nice rubber in my hand, or I'm very good at PowerPoint design, then it will get more and more confusing to start changing these things. So this is not very extensible either, because now I want to put this in a wiki and somebody wants to add a new functionality. I need to share this diagram to them so they can start doing changes and keep track of all the numbering that is going around, and it becomes very complex very fast. And this is half of the use case, and it's already a mess of arrows and numbers, and I don't want to even know what this will end up. And I imagine many of you trying to make this event-driven application, I can see some people nodding already, have faced this problem, because this is the way we are trained. Let's do boxes and arrows. And then we are like, fuck, I'm going to code. Sorry for my English. And we go directly to code. Coding is easy. Coding is nicer. I don't want to face these drawings. These drawings end up in the wiki the first 2 days. Nobody keeps them updated. Then somebody comes. It's like, what the event is doing? I don't know. Let's create a new event, whatever. Yeah, I know the feeling. So I ask DALL-E. You all know DALL-E, don't you? It's very trendy right now. It's an artificial intelligence that you tell them something and they draw it for you. I don't know which gender to apply to DALL-E. I'm Latino, I'm Spanish speaker, so I like to put genders to things, so I might refer to he or she or it. I don't know what is the right thing to call it. So I asked, what is event-driven applications for you, dear DALL-E? And he drew this. And I think this is the perfect representation of what event-driven applications are. Oh, it starts so easy, it's cubes and lines, and then that's my brain. And yeah, that's my brain, and that's all of your brain. So today, I'm going to teach you a method that works for me and many of the customers that are trying to build event-driven applications that is less brain explosive, that at the end of the day is what we want. We don't want to leave our gray matter in the floor where we are working. We need it for other things, like playing games. And I will show you this way that is cheap to do, so you can iterate on it, and you can iterate on paper and not in your code. It's cheap to maintain, and it's easy to extend. Sounds very magical, but you will see. And then I will share some best practices of using EventBridge. So for all of that, I need that everybody knows what EventBridge is. I know this is an event-driven architecture conference sponsored by AWS, so 80% of the room is super familiar with EventBridge. Sorry for that. It will be 2 minutes, but I need to get everybody in the same page. I don't want people falling asleep. Half of my talk is agnostic what technology you use, but then we will get into some demos and some coding and things like that, and I want you to understand. So for the people that know what EventBridge is, this is my Twitter handle. This is the EDA hashtag. While I explain what event-driven with EventBridge is, go make a nice tweet, take a picture, and put it online so you use your time for something useful. For the rest that want to know what EventBridge is, you have 2 minutes to understand the basics. The first one is EventBridge is a managed service. So it's an event bus. I've been doing software architecture and development for 20 years. I know I look young, but that's because I live in a wrap paper and I put a lot of cream in my face and have a lot of makeup. But yeah, I've been in the time where there was event buses in enterprise architectures, and they were flaky and scary, and that's why we stopped using them. Now we have this amazing technology that is not flaky and it's not scary, but does the amazing thing of collecting all the events from one source and sending them to targets. And you don't need to scale it, it scales magically. You don't need to understand how it's configured. AWS does all for you. That's the magic of managed services. And at the end of the day, it decouples your producers from your consumers. Usually producers and consumers are microservices that are producers and are consumers at the same time. But the idea is that you can remove, for example, the inventory service, and you can change it for other service. And if it's agreed with the contract, that is the schema of the events, then we're fine. So there is some concept I will be using multiple times during this talk. The first one is event source. AWS services are event sources. S3 will say, send an event to EventBridge, say, hey, a new file is created, I have an event for you. An alarm will send an event, hey, a new alarm is created. Also your custom applications, and that's when it becomes more interesting. You can send events to EventBridge, and also SaaS applications, but we are not getting into that monster yet. Then we have the event buses, and those are very important. We have the default event bus, is where AWS services will send messages, and also your custom applications if you configure them. Then we have the custom event buses, and that's my favorite place to be, is where all the events from your applications can be. So you have a nice pipe where all the events are, and you can work with them. And then we have the SaaS buses, but we are not getting in there. Then we have the rules, and rules are like, if the event comes from here, take it there. And that's it. And then we have targets attached to the rules that are the places that will receive the event. You can invoke a Lambda, you can send it to a queue, you can send it to many other places. So those are important concepts. How it works? Well, a source makes an event, and the event gets analyzed by all the rules in the bus, and if it matches, then it goes to the target. And that's kind of what you need to know about EventBridge in order to understand the talk. Now, let's go back to agnostic world architecture land, and I will tell you my magic secret to design these applications. But not yet. Stay tuned. Keep on watching. I want the retention. I will tell you 3 things to have in mind before getting into there that will help you to design these applications. The first one is what kind of events you are listening. And if you were here for Dave's talk, you will get way more out of this because it's a very brief thing. But I want to talk a little bit about the events itself. The first one is idempotency. I'm not an English speaker, so I hope I didn't destroy that word. Basically, it's a mathematical concept when no matter if you get 1 and 2, you always return 3. That's math. Always with the same inputs, same outputs. And that's how you want your functions to behave, or your service, or whatever it's the thing. So same events, same thing. Imagine you receive an event, hey, you need to make a payment. Okay, I make the payment, I process the payment, I return payment ID, order ID. Great. Oh, the event comes again. Why it come again? Well, because most of these services have the promise that they will send the event once, but they might send it twice because of network issues, because, I don't know, you were lucky and you got it twice. But your service needs to be prepared for this type of things. And what you do you process the payment again? Maybe no. Do you send an error? Maybe no, because your customer doesn't care that your internals are like that. What you say, okay, the payment was processed with exactly the same order ID and the same payment ID, for example. And then you start having duplications. That's why it becomes very important, the idempotency. There is ways to address that, but that's a whole talk that you can find on previous reInvent. Then another thing is how events are designed. We have different types of events, and they've covered this very well, but I will talk about 2 types. There are the sparse events, the events that don't say too much. They have as little information as possible, and the full description events. These are like me, they talk a lot, they say everything. Both are great, but they have their problems. And this is important to have in mind when you are designing this application. Sparse events are great, you have minimal amount of information, but sometimes down the line, Some services might need information. And if you have an event that is, or a system that is very big and with a bigger scale, that might DDoS your service on the top, like, oh, I need to know the order ID, I need to know what is inside this, I need to know, and then your order system is like, poof, where I'm getting all these requests. So you need to be careful on when you are designing the systems on who needs what information and how you are getting resolve that. This is great, for example, if to put little amount of information. If you are working, I don't know, imagine you have a bus card and you bought like 10 bus tickets. Maybe you don't want to put inside the event how many bus tickets you have left, because that's something is changing all the time, and you will need still to pick that information from the service because it's a number that changes all the time. But maybe information about an order that is static, you might want to put it inside the state. So thinking about how you're going to work with these events is very important. Then we have the full state definitions. And here, things you have to have in mind. Security. These events are sent to the world. Don't put private or confidential information in there. And if you do, please encrypt it. You can encrypt messages. Then the schemas are a contract between the different parts of your application. So you have to have in mind that schemas should be backwards compatible. They were asking Dave about versioning. You can version as well. But have in mind that, for example, if you have an event that is sending the birthday and the age, somebody might align by say, well, they're sending me both. Why I will calculate the age? I will use it, whatever. And then, we have the age, let's remove it. And then, poof, explosion down there. It happened to all of us. So it's good to know that whatever you put in the schema, somebody will be using. So be mindful on what you need to put in the schema. So for me, the best option is the middle ground. Don't put too much, don't put too little. Be very mindful on how your events are going to be used down the line. And when they need to add more things, you add more things. Try not to remove. And then finally, and this is something that our brain gets very confused, an event triggers one service. Good, we are fine. Linearity, our brain is great with that. That's why we like traditional services, one thing next to other. One event triggers 1, 2, 3, 4, we don't know how many services, and then we have this fractal of parallelization going on, and then we are like, ciao, I don't want to know about this. Can I go back to do Java programming in the 90s? Yes, please. So it's like, yeah, this is becoming very, very confusing for our brains, and this is where we need a good design, because parallelization is the magic of these event-driven applications, and we want to take advantage of it. And then finally, an event is not triggering anything yet. And this is a good recommendation to add events, even if you know that they're going to the void, because that allows you to extend your service. So with those things in mind, let's go back to my e-commerce. And here I draw some of the things that each of the service expects from each other. And let's work on the use case. I want to create an order. And I'm about to reveal my secret sauce. Are you ready? Are you awake? Good. A table. I know, I'm magic. It's amazing. It's a table. That's the only thing you need to know in order to design event-driven applications. Make a table. We all love tables. They are easy. Open a spreadsheet. You can add, remove, move, copy, paste. They're cheap. We can embed them into GitHub. We can change them whenever we do a code repo change. We add a feature. We can change the table. It's not in a wiki. Totally different system that developers don't care. So a table, that's the magic thing of doing event-driven applications. Have a table, and this table works for me. I have talked with many customers. They have different columns in the table. They work little different, the flow. So that's up to you to find what is the right level of columns and how you are going to structure this. I usually do one table per use case, because that's been working for me, but you might have a different perspective. So first column is the asynchronous. In the case of ordering, we have an API gateway that triggers the whole process, create the order. Comes from our web front. Second one is the input event. In this case, we don't have any. Then we have the service, in this case, the order microservice. Then we have the action, create the order. In our serverless land, word is the function name. And then finally, we have the output event. And this output event, then, we put it in a general table, another table. We'll have a lot of tables by the end of the day. where we put all the events. And this is, again, everybody does it different, so you need to find what is the level of table that works for you. I cannot tell you this is the only way to do it, but this works very well, because here you will document all the attributes, you will know where you can find these events, you know who produced them, you can start extending your application. Now, next step in our application. The order is created, we have put them in the database. Now we want to reserve the item. One more line. And this time, it's an input event, because this starts to be an event-driven application. I'm drawing this architectural diagram here. That's not needed for you. This is just for you audience people watching this, so you know how simple the problem is solved. It's like basically a Lambda function and a table. So you don't need to put these diagrams in your own application. And you will see that some of these events, some of these actions will create 2 output events or more, depending on what you need. In this case, the item is reserved if everything is good. The item is not available if there isn't a problem. So you can work with those, and you should. Again, we put the element in the table, and then we move on. OK, now the item is reserved, and you start getting the drill. It's very nice, and it's very flowy. Just keep on going until you find the right end result. And you might say, hey, Marcia, this is amazing. This looks beautiful. You're going so fast, la, la, la. The truth is that when you build this, you might spend a while iterating around. This is the end result. I'm just grab my table and put it in nice slides. But when I was doing this type of things, I was thinking about OK, I need to make an order. Well, I need to pay. I need to send it. And then you start realizing things that go in the middle. And then it's so easy. Add a new line, and then you add it there. You change, you copy-paste, and you move forward. So it's very, very cheap to iterate until you have a flow that works for you. So you keep on adding lines and activities to your flow. So different microservices again. Now we are getting the delivery estimate. We have the price of the product. We have how much it weighed. We have the address of the customer. We get estimation on how much the delivery will cost. And then we go and make the payment. And you see that everything flows and everything is very simple. Good. But what happens if there are errors in our system? Because we might have errors. Maybe the customer didn't have money in their account, or the customer was not at home, or the item was not available. I mentioned that we have these 2 events. One is for the success, one is for the failure. Well, the failures are designed exactly in the same way as success. They are events that need to be addressed. So whenever you have 2 events, or 3, or as many as you need to work with all the events that you have, unless they're end state events. So if you have, I like to mark my events in the table with end, because that means that you will not find that event in the input table anywhere, because that's an end state. But other events, they all need to be handled, because if not, that means that your application is not complete and you will have problems. For handling errors, I recommend you to follow the saga pattern. So every action that has a side effects, change a table, create something, do a payment, you need to do a compensatory action to solve that. So, OK, you create an order, cancel the order. You made a payment, please return the money to your customer. You start a delivery, and delivery got canceled. Well, that will trigger all the compensatory actions that will take you to the beginning. So have that in mind. I have seen some customers that in their table, they have a star or a mark to which actions in the table, for example, if you go here, have side effects, because some of them don't have side effects. Some of them are just getting information, and that's fine. You can get information, nobody got hurt. But if you do a payment and you don't return the money, somebody will get very, very angry. So you can have another column that is like a side effect, and then it's very easy for you to go and recover from there. So another thing that can happen is one day your PM comes and says, hey, Marcia, we have a lovely system, but you know, when the customer makes an order, they don't know if they will get it in their house. Maybe 5 days later, they have a box in their house or not. So we need to add some kind of notification to the customer to let them know that they kind of like where the order is, because it's lovely, this asynchronous word, but it likes to notify. So now you need to add a notification service when the payment failed, when the item is not available, when the delivery started. Oh my God, this manager. So I go and change all my table. No, my dear, you don't. You just add one line, and you listen to all the events that you care for, and you send an email. That's the magic of event-driven applications. No need to change anything else. You have events for when the item is not available. You have event when the payment was failed. You have an event when the payment was successful. You have all that information. So you listen to it, and you send an email when that happens. And that's the beauty of it. So let's show you some code, some caveats. The code is available, so yes, it's available. It's in a GitHub. It's at the end of the presentation, so you should not leave until you see the code repo. It's in CDK and SAM if you're interested in. And I will show you the SAM version because it's simpler to show, but you can get exactly the same app in CDK. This app is the same e-commerce, but instead of putting each microservice in its own package and whatever, I put everything in one SAM template, so it's easier for me to show it. But you can have it in multiple accounts, in multiple microservices. It will work. So this is how it looks. And here I have everything. So each microservice is one Lambda function that does all the actions. So just for letting you know, this is a demo. So here we will go directly to the order function. And in the order function, you will see everything. But the part that we are interested in is in the API gateway that invokes this thing. So again, this is infrastructure as code. We are triggering this function with an API gateway. Basically, a customer bought a product, and boom, this Lambda function gets triggered. And then what happens when this Lambda function gets triggered is that an event will get put into the bus. So here I'm just filtering if the request comes from API gateway, and then if the request comes from API gateway, we go and create an order. Here, basically, we're just creating the order event and putting it in the EventBridge with send event create order. The order created is the action, order is the payload, event bus, it's environmental variables, and the event source is the order service. And that's it. Now we can go to our SAM template and see which function gets invoked when the order is created. And here you can see that is the inventory function, and you can see little under that you will see the rule. Here it is, and this is the rule for the event bus, for all these rules with this payload, for all this event with this payload that trigger this function. That's, I told you that this is all in one big function. And then we can see, well, if the order is created, we need to put this message. But first, we need to reserve the item in the database. So we go do some magic particle in our Dynamo table. That's a different talk, so don't get into there. And then we will put, if everything goes well, we can put the event in the table. So you will see if you're building this as separate Lambda functions, they will be tiny, whiny, super simple, super fast Lambdas to run. Then we see what Lambda function this item reserve triggers. Again, the inventory function, but then a different part of it is the item is reserved. And again, we are putting the event in the bus, but first we are getting the information from the Dynamo table. Then the item described triggers the customer, and so on and so forth. And this is basically how it looks, and it's pretty straightforward. The best way to see it, I sometimes like to run this. So for running this, I'm using Thunder Client. This is an extension from Visual Studio Code. Basically, it's a REST client that allows me to not leave my IDE, so I don't get hooked in Twitter. And basically, you just put endpoint. This is the API gateway. Creates an order for customer 1, item 2. This is a very simple demo. It only can, every customer can buy one product at a time. This is a synchronous call, so the response will only be that. Basically, the order ID is the important thing. And then from there, we need to figure out what happened. So what we can go and do is check the logs and the database to see if this works. I know, we all have been there. Maybe not the most efficient thing to do, but I know as soon as you download this code and deploy it, this is the first thing you're going to do. So we can go and use the Serverless console, another extension from Visual Studio Code I love to use, so not leaving the IDE, where I can see the logs and I can see the database. And here I can see the logs for the create order. I can start seeing that the order was created and things are moving forward. So that's good. Now I want to see what happened in the order table. I can go and explore that. So everything is very decoupled and very isolated. So if you don't know what is going on, I still don't know if the order has gone through, has been delivered. No, the payment was canceled. Okay. Now we need to figure out why the payment was canceled. Was the account didn't have money? The delivery was canceled? What happened? So now we are starting working in this live debugging that we all have been, trying to figure out what happened. Well, in the inventory table, everything looks good. I know the initial stock, everything is available, so nothing was sold. Okay, we're good. Now we are in the payment table. Oh, the payment was canceled. How many times you have been here trying to figure out what has been wrong, and you have like this amount of things doing different things at the same time, and everything is very decoupled? We all have been here. So now I kind of figure out that the payment went through, but then the payment got canceled, so this is a saga action, and I was like trying to figure out what went wrong, and I can't. So one way to do that is by using one feature. I mentioned you the custom buses, and by using custom buses, you get this right away. And it's keeping track of all the events. So I will show you how it's so simple to keep track of all the events in one place. And you can do this debugging that we all do, let's be honest, very simple. So the first thing we are going to do is to create a custom bus. And you will see that, for example, the order function and all the functions involved in this process are putting the events, and they are using the custom bus as the trigger for the rules, and putting the events in there. So that's the bus we are using. And then this bus has a function, this service has a function that is listening to all the messages in the bus. So everything that goes through the bus triggers this Lambda function. And what this Lambda function does two things. Writes in Dynamo every event, and it writes it in CloudWatch logs. Why? Well, you will see in a second. But this is something you can decide which structure you want to give to your logs, and what structure you give to your table. I think I've been doing this talk a couple of times, and I already will throw this code and write it again, because I think there are better ways to do it. But I think the important thing is the idea. So now we have this function that listens to all the events in the bus. And now we want to debug this problem, like why the customer payment was canceled, what happened. So the first way is to go to the logs. The logs are great. You are working alone in this environment, and you tail the logs, and you start doing things. And every time there is an event, things get logged there. You can see all the things that are happening. So we can see it in action. So this is the previous execution, and you can see all these things are different events for the same transaction. The order was created, the item was reserved, the elements were getting the price from the inventory, the item described, then we are getting the information from the customer. Everything is tailed one to another, and you see the full event description. So it's very easy to code and to start navigating this while you are coding. You're alone. That's the most important thing, because if you have other people working here, you will have events in the middle, and it will not be as nice. But this is in your own local world. This works very well. You tail it, and it just goes. And you can do live changes and push code very fast, and things start moving quite fast. This is a way I like to do. So here we can start seeing that the item was removed. That's good. The payment has gone through. The item was removed. The delivery started. We're almost there. And then we will see what was the problem. The delivery was canceled. So basically, the user was not at home, and that triggered the saga pattern of why the payment was canceled. So this was a super simple way. In one place, everything is located in one only place where you can go and navigate what happened to your use case and start debugging and tweaking it. Now imagine that you're in a production environment or test environment where you have all your colleagues sending events, and it's not that simple to get a clean CloudWatch log where you can see everything. Then is where Dynamo shines. So you don't need to do both strategies. You can do one or the other or neither. That's up to you. But here in Dynamo, you have all the events in one table. So you go to the table, and you will see all the events that happens. Each event takes one line, and you can make this table as you need. So here you can see that if you open any of the line, you will see the whole event. So all the payload for the event, everything that we were seeing in the CloudWatch view is here. It's just organized a little different. And the good thing with this is that you can search. So now you have the order ID. You know that the previous order failed. So what you can do is go and do a search. This is not a very efficient search, but for testing purposes, works very well. And you will get a list of all the elements that are matching that order ID. And with a little scrolling down, you will get the delivery was canceled. So this is very efficient for start debugging and playing in your event-driven applications. If you want to do more deep dive debugging and more performance debugging, X-Ray will help you to find the bottlenecks in your applications, what things perform, how things are moving forward, and what you need to do, because EventBridge is not automatically tracing all the requests and all the events that are being pushed. You need to wrap all the put event operations with X-Ray. So whenever you're doing put event in your Lambda function, you need to basically have these 3 lines on top that you are importing X-Ray and you're wrapping the SDK library. And you will get something like this at the end. Very useful, but this is nice because you can start seeing all the nuts and cracks of your application. This is my favorite feature. When it was announced, I was like, yes, this is what I need in my life. API destinations are a different type of targets. Targets are Lambda functions get triggered with a message like match the rule, boom. We put a message in the queue, when the message matches the rule, boom. And API destinations are an HTTP endpoint that gets triggered when an event matches the rule. So you can send messages to these API destinations from your EventBridge. And in the case of our application, what we will do, we are small e-commerce. We don't have money to have a planes and a delivery company ourselves. So we are outsourcing our delivery. But we still want to be event-driven. So whenever there is a new product order coming in and everything is good, we have calculated the delivery, we know the price, the customer has paid, the item has been removed from the inventory, we will send an event using API destinations to our external delivery company, to our third-party delivery company, like, hey, can you deliver this for me? This is all the information you need to know. And there we can have security, so it's not an open endpoint. You can have API keys, username and password, OAuth, whatever you like. And you can also have some rate limiting, because serverless scale, everything is good, but our third parties sometimes don't scale the same way. So how you build this? The first thing you need to build is a connection, and this is a security aspect. I'm using API keys, but you can do anything else. You should integrate it with Secret Manager or something like that. Please don't put your API key in your GitHub repos. I have to say that, just. And then you build the API destination. The API destination, use that connection that you created, the URL from your third party, the method, like post, get, or whatever you need, and then you say, what is the rate limit? So you're saying, hey, invoke this 10 times a second. Please don't kill this thing, because, legacy systems or third-party systems, you never know. And because you never know, you always need to use dead letter queues. Yes, because dead letter queues are very important in event-driven applications, but they are even more important when you don't control them. In this case, we are calling a third party. How many times third party are, what is the availability of your third parties? Are they 99.999%? Maybe not, mostly not. So you don't want those events that you're sending. I don't want, when a user creates an order, send the order to be delivered and the message is in nowhere, because my third party, I don't know, have a hiccup in that specific moment. So dead letter queues gets all the messages that were not delivered inside a queue. And then you can trigger an alarm, or you can reprocess them automatically, or you can go at the end of the day and process them again. There is some properties, like how many times you retry, for how long, and so forth. This is a normal SQS queue. Another thing you need to have in mind is the multi-account architecture. What I show you in the demo is great, but it's not realistic. In general, we have different microservices in different accounts, and you can do that when you're working with EventBridge, no problem. Everything is in a different account, centralized bus, sending to other accounts, and that's how you should have your applications if they're big enough. Another thing, and this links to the next talk that is happening, about patterns and application integration. EventBridge is amazing, but there are other amazing tools. Pick the right tool for your problem. So EventBridge works great to coordinate multiple microservices together and to create this thing. But if you need more specific workflows where things need to go one after the other in a particular order, or you have things within your microservice that needs to follow, like instead of having a huge fat Lambda function, you cut everything into smaller pieces and you use APIs, and you want things to go from here to here and then do retries and things like that, use step functions. Or you need to send notifications to a customer, use SNS. You have a huge amount of traffic, use Kinesis. So pick the right tool for the problem. Don't stay with one tool, because that's what we do in AWS. We have multiple tools to help you out. Finally, I want to talk about global endpoints. This is quite new. And this is for those customers that need that reliability, that high availability. I don't care, but I need my app to be up all the time. And this will help you if there's any problem in a region that the service will take care of. So you will have a global endpoint that is global, is not attached to any region, and it will define a primary EventBridge bus. So that endpoint will send it directly to the bus, and if everything is good, then things get replicated in your secondary region, but nothing happens. All your targets act like everything good. But now imagine that there is a problem in a region, and your primary region is down. What happens? Automatically, an alarm will trigger the failover. So instead of sending the events to your primary region, will be sent to your secondary region. And then it will also replicate to your primary region just when its app is ready to take over. I cannot go into the details of this, but if you go to reInvent, you should go to my talk there. I will be deep diving a lot on this, so just see you in there. And to summarize, event buses help you to decouple your applications. You already know that, but now you know how to design them in a way that you don't explode your brain in the floor. Use events, tables for your use case and for your events, and then it will be easier. Put them inside your GitHub repo so your developers are responsible whenever they change the code to update the tables as well. So then you can have processes in the place when you're having your pull requests. Design the events with the idea of thinking how others are using it. Keep a central log of your events if you need. Don't forget observability if you need that. Learn the features from EventBridge and use other services as well, the right services for the right tools. And this is the link for all the videos and code and everything, where I go a lot in details into how to build this application, how to do it with SAM, how to do it with CK. Every piece of functionality I talked today is there. And I will keep the link on the screen, so don't worry if you didn't take the picture. Thank you very much. If you have any questions, I will answer some now, but I will be in the Serverless Espresso booth after here. So thank you.